students. I welcome you for this today's session. So in the last class I explained some concepts about that sound, okay? So how sound will be travel in that different mediums, right? And sound cannot travel in that vacuum, and then some characteristics properties also I explained. Okay, anyway, in today's class I will revise that some concepts regarding that characteristics of sound waves, and then we will move to that graphs, which are different graphs, and then we will solve some problems based on that speed. Okay, so just after watching this video, just take your book and read it once, and then only you can understand in the better manner. Okay. Okay, students. Today I'm going to revise that characteristics of sound wave. Okay. So what are the characteristics? What are the characteristics of sound waves? See, in the last class I explained this. What are the characteristics of sound waves? So anyway, so there are three major characteristics in this lesson they given, particularly in the sound lesson. Okay, so first one, it is called that frequency. Okay, so the frequency is very important, and the second thing they given is amplitude. Okay, so amplitude, and the third one is actually speed. Okay, so these three things we are going to see, and I'm going to revise these three things today, and we will see that further concept. Okay, the first one, you have to know that, see, when you look at that pressure variation or density variation, so for that we have to draw the graph. Okay, see, this is that the speaker, loudspeaker. So this is the source of sound. Okay, so this is the source of sound. Here I will write that is the source of sound. So from this it will come, the density variation will be varying that. So the particles and all, first it will be compressed. Okay, so that means the distance between the two particles will be very less. That means that at that compression state. Okay, so see here this one. Okay, and here I'll draw some more particles. Okay, then only you can understand. Okay, so this is called the compression state, and after that it will be somewhat, the space will be enlarged. Okay, so here the space will be enlarged. So this is called what is that? This is called compression, and this is called rarefaction. Okay, and the same way, like it will go this kind of only. Okay, so if you look at that pressure variation, this is called this particular thing, this particular box. So number of molecules in that particular volume, that is we have to say that is called density variation. Okay, so this is called density variation. Okay, the pressure variation means we have to look at that same way, like source, we have to draw that source, that amplifier, and the same way, like the lines will be, okay, if you take on that, lines will be more closer. Okay, and the same way, this is called the same way compression, and if the lines and all, it will be very less. That means the distance between that will be very high, means that's called a rarefaction. So when you plot the graph between these two, okay, so when you plot the graph between these two means, so what will happen? So first from this beginning, that means from the 0 point, so this is called your here density. Okay, so density or pressure variation. So here density or pressure. Okay, so if you have plot the graph between the density and pressure with here what is that given in, means average density or pressure. Okay, so here distance they given, so distance. So what is the distance? Okay, if you look at that, here the state will be highly compressed. Okay, so that means, so your density or pressure will be slightly increasing from 0. Okay, so it will be increasing. So after that, when it will go after this point, what will happen? So automatically it will be it will go to down, right, because of the relaxation. Okay, so and it will go again, it will go and it will come down. So this kind of only the waves moving. Okay, So if you draw the graph between that density or pressure with respect to distance, so you will get this kind of only. And see this area, so I shaded this area. So this area, it is called compression. Okay, so this is called compression state. Okay, and this end it is called rarefaction. Okay, so rarefaction. Okay, so one compression and one rarefaction. Okay, students, so these are the major category they given in your book. Okay, so what they given, the major concept is actually the compression regions. The compression regions are, it will be highly pressurized, and the rarefaction, it will be low pressure. So that means where the particles and are very crowded, that is called compression. If the particles are gets what's called distance between the two particles will be very high, that is called rarefaction. Okay, so the distance between here the compression and the rarefaction, it is called that wavelength. Okay, so one compression, so here this is called compression, no? So from here to here, this is called wavelength. Okay, so that means what is the thing is the distance between two consecutive compression or two consecutive rarefaction. Okay, so this is called, I will write here, this is called wavelength. Okay, so wavelength, and wavelength can be represented in terms of what is called, it is lambda. Okay, so the unit of that wavelength is usually represented, that is called lambda. Okay, so lambda. Okay, the letter is called this kind of the symbol, this is called lambda. So remember that, students. So lambda is very important. So wavelength is nothing but two consecutive compression, the length between the two consecutive compression, and otherwise the consecutive two rarefaction, it is called, it is wavelength. Okay, so okay, what is that top position? Okay, so what is the top position they given? So I will write somewhere later. So this is that called top position, no? So this top position, so this top position is called your crest. Okay, so what is this one? This is called crest. Okay, and the bottom position, it is called trough. Okay, here. Okay, so this is called crest and trough. Okay, so this line, so I will take one more thing. So this line, that horizontal line, no, this horizontal line, it is called average distance. Okay, average, so average pressure or average density. Okay, so this is the graph between the density and distance between them. Okay, students, and see what is mean by frequency. Generally we say, what is the frequency? So frequent means generally we say that how frequent the event will be occur. Last time I said, one, if you beat the drum means in the particular time they assigned means, so within that particular time how many times you beat means, that is the called the frequency. Okay, so frequency generally we say that the number of oscillation produced in particular 1 second. Okay, so otherwise we can say that so what is that frequency? So that means we will say that compression and rarefaction, so that event will be occur within the particular second. Okay, so that is called frequency. Okay, see when you look at that, so from here just listen, so from here, so it will make, see here it will go up and it will go down. Okay, so this kind of, okay, so once it will go from that maximum value and minimum value and again reach maximum value means, that will take one complete oscillation, no? So that for that how much time it will be required, that is called your time period. Okay, so how much time it will be required for one complete oscillation, that is called time period, they will say. Okay, so anyway you have to know that. So what is mean by the frequency? So number of oscillation produced in 1 second, so that is called your frequency. Okay, so frequency, what is that letter? So frequency actually, so frequency, the unit of frequency which is equal to hertz. Okay, so remember that, that is hertz. Okay, so after the scientist name Henry Rudolph Hertz, so they said hertz, so simply Hz. Okay, frequency can be represented in terms of hertz. Okay, and one more thing I said that what is that relation between that frequency? Okay, so frequency letter actually, this is called nu. Okay, so what is that frequency letter? This is called nu. Okay, Nu. Okay, so we called it as Nu. So what is the relation between frequency and time period means? Frequency which is equal to 1 by T. Okay, so remember students, this will be very important. Frequency which will be equal to 1 by T. Okay, for example, if you take different kinds of musical instruments and see, for example, violin or flute. So if it is played at the same time means in any function or orchestra, so sound travels through that same medium, that is air. So sound travel in that particular medium, that's called air. Okay, and it will be arrive to our ear, no? So okay, so both the sound travel at the same speed and same speed only, no, both that sounds, but that you have to know that. Okay, so it will travel in that air. Air is a medium, right? Okay, but we receive that different kinds of sound. So that different kinds of sound means that will be represented as pitch. Okay, so pitch. So the frequency will be determined that what is that pitch. Okay, so actually the pitch which represent that. So how much the frequency interval between that. For example, see, I will say that I will draw the graph here. Okay. Okay, so just a minute. Yes, so here, see, if I draw the graph here, okay, in between that, so wave disturbance, in between that wave disturbance. Okay, if you plot the graph between the wave disturbance and the time, okay, so in the x-axis if you take time, and in the y-axis you have to take that wave disturbance, means if you plot the graph in between that, see, low pitch, that means the object which will vibrate, it will take lot of time, more than time to vibrate, right? So for example, if you take a different musical instrument means, so one is producing low. So if you plot the graph between wave disturbance and time, see, if it is low pitch means the distance between that frequency interval will be very high. For example, see the distance. So this kind of will go. Okay, so if it is, this is called a low pitch. Okay, so low pitch. And see, when you take one more graph, see for this, if the wave is going this kind of, okay, same way you have to take a time in x-axis, and here that wave disturbance. Okay, so wave disturbance you have taken, wave disturbance. Okay, so when you look at that, the distance between here the two wave length will be very less. Okay, so that means the frequency level, so the frequency level will be very high. So when the frequency level will be very high means the wavelength should be least distance, the distance between that wavelength, two successive wavelength will be very less. Okay, so it is nothing but the object which will produce the vibration in very less sound, that means very less number of time if it takes, mean that is called high frequency. If the object, that means the source, it will take the vibration to take long duration, to long time when compared to the previous one, that is called low pitch voice. Okay, and one more thing, they will say that what is called loudness. Okay, so loudness or softness, so this one, so the amplitude will be, say that you are deciding that whether it is a loudness or softness. So what is that amplitude, sir? See, same way here, so when you draw the graph, okay, so this is, you have to take time, so time here, and wave disturbance here. Okay, so wave disturbance. Okay, so when you draw the graph, if you look at that, the maximum peak position, okay, so this is called your maximum point. Okay, so from this mean position, so this is called your amplitude. So amplitude generally say that A. Okay, so it is called as amplitude. So amplitude is nothing but the maximum displacement from the means position. Okay, if you draw the graph between the wave disturbance and the time, so the maximum disturbance, okay, so maximum disturbance in the medium on either side, even this side also, and this side also, and this side also. Okay, so the maximum disturbance, that is called your amplitude. Okay, so that it will represent in terms of letter A. Okay, and the loudness and softness of sound will be determined by its amplitude. So whether the amplitude height will be very high, mean this is called loudness. Okay, so this graph, it is called loudness voice. Okay, louder voice. Okay, and whether if you draw the graph. Okay, so if you draw the graph here, so I will draw one more graph. Okay, so if you draw the graph, if you look at that, the height will be, okay, from the mean position, same way here wave y-axis, and here time in the x-axis. So here the distance between from the mean position to that maximum level will be very less. Okay, so when compared to this case, so this will be very less. That means this is called your softness. Okay, so the loudness which one already you studied. Okay, so loudness which is directly proportional to square of that amplitude. So this thing you have to know, students. Loudness will be directly proportional to square of amplitude. Okay, and these are some basic graphs I explained in the last class also. And as I said, what is meant by the speed of the sound? Okay, so what is that speed of the sound? Actually the speed of the sound will be defined